Hello everyone, welcome to Belmont's Math and Science Learning Center lecture series on Math 1010 Quantitative Literacy. My name is Brandon Stevens, and not only am I a lecturer at Belmont, but I have the pleasure of working in the Math and Science Learning Center. We at the center strive to help students succeed in their difficult math and science courses, whether it be through no reservation tutoring or simply providing resources to students so that even when we're not on the clock, they know where to look for more information on their subject. And what better way to provide resources than to create our own. So this lecture series has several videos that hit the main talking points of many of the quantitative literacy classes here at Belmont. And so whether you use this as a concurrent study tool, you learn it in the class and you watch a video the next day, or maybe you're using this to study for an exam, or maybe you're coming back to this a year later thinking, what did I learn in this class? Hopefully these videos help make those little connections that maybe you missed during the class, or at least strengthen or bolster those connections and help in some way. So let's go ahead and get started. Our first topic of conversation is about means and weighted averages. So whenever I say means, I'm sure you have an idea of what I mean, and it actually turns out to be a little more complicated than that. But going to what you probably are thinking, back in probably third grade, we're taught that mode is the most, and median is the middle, and mean is the average. And mean is always the weird one because you actually have to do math, you have to add everything together, divide by the number of things. So for example, let's say our data set was the numbers 2, 6, and 7. Maybe this is the number of hours of sleep we get 3 nights in a row. We only get 2 hours of sleep one night, 6 hours of sleep, 7 hours of sleep, and want to figure out the average number of hours. We would add all of those numbers together. So 2 plus 6 plus 7, and then take that total and divide it by the number of objects there were in the data set, which is 3. In which case we get 15 over 3, which just so happens to be 5. And that number right there, we refer to as the mean. However, if we want to be more specific, we're going to say that this is a particular type of mean. In fact, we're going to call this the arithmetic mean. It's the mean that will work in most scenarios. When we say mean, this is the one we're usually going to go to, but there's actually a few key scenarios where this definition of mean doesn't actually work. It doesn't actually give us an accurate picture on what our average is in this case. But again, this is what you're going to go to in most of your scenarios. It's probably the one you're most familiar with. A second type of mean, before I go into too much detail about it, we have to talk about this idea of a growth factor or a decay factor. Now these things, they come up a lot when we're talking about exponential functions, so I'm sure this will come up in another video. But the idea behind it, the context behind it, is let's say we're renting an apartment, and 1 year the rent is $1,000. But after 1 year, they decide to increase rent by 2%. And we want to figure out what our new rent is going to be. Well, we can take that $1,000 and multiply it by what's called our growth factor. And the way to find our growth factor is to take this 2%, change it into a decimal. So how we do that is we take the decimal point, move it 2 to the left. So we get 0.02. And then we're going to add 1 to it. So in this case, that is 1.02. That is our growth factor. Now let's say by some miracle our rent actually goes down by 2%. A similar thing happens, but instead of just 0.02, we have negative 0.02. We add 1, and so we get 0.98 as what's called our decay factor. So that's what our growth and decay factor is. Now we'll actually get back to why we're even talking about this. We're going to do means, averages of growth factors. And we'll figure out that in this case, our normal definition of a mean isn't actually going to cut it. So let's say, for example, using the same numbers as before, our rent increases by 2% 1 year, and then it's going to increase by 6%, and then it's going to increase by 7%. And we want to know the average percent increase of our rent. Now, some of you might think, okay, 2 plus 6 plus 7 divided by 3, we already did it, it's 5. Turns out it doesn't actually work. We have to use what's called the geometric mean. So our first step in this is to convert all of these to growth factors. And just for ease, it's going to be 1.02, 1.06, and 1.07. And you can figure that out. Move the decimal to the left, add 1. What we're going to do with those growth factors, instead of adding them, we're going to multiply them. So we're going to take 1.02 times 1.06 times 1.07. And from there, instead of dividing by the number of things, we're going to take a root, and we're going to take the third root because there are 3 of them. If there were 4 of them, we would take the 4th root, so on and so forth. And so you can put that into your calculator. If you want to know where to go, you go to second, and then, or you go to math. And it's the 5th one on mine. It might be different in yours, but that's how you get different roots in there. So you take the third root of 1.02 times 1.06 times 1.07, and you get 1.0498, which now we want to convert this back into a percentage. So we're going to reverse the process we did before. Instead of adding 1, subtract 1 to get 0.0498, and then move the decimal to the left. So we have a 4.98% increase. That is our geometric mean. And we can use this to set up a similar exponential function in order to predict our increases later on. But there we go, so 4.98%, that's our geometric mean. Only used in this context of growth factors. And it gives us a clearer picture of that average. Okay, that's our second type. Our third type is going to be used when we've got different rates that we're looking at. We want to average those rates. So let's say, for example, we've got 3 stretches of road. So there's our first stretch, there's our second stretch, there's our third stretch. And let's say, for example, that each of these is a 30-mile stretch. They're all the same distance. Let's say we're driving this stretch and the speed limit here is 20 miles per hour. We're in just school zones all the way down, or neighborhoods, or whatever you want to say. Our second stretch, let's say we've gone up to 60 miles per hour. And then let's say our third stretch is 70 miles per hour. And we want to know what is our average speed, what is our mean speed for this entire length of 90 miles. Now, some of you, again, might be thinking, okay, 20 plus 60 plus 70, add them up, divide by 3, you get 50. But the problem with that is, remember, the distances are the same. Not the lengths of time. It's going to take you longer on this stretch than it is on this stretch, because you're going so much slower here than you are here. So we have to use what's called the harmonic mean, and that one is a little trickier. It's going to be a very complex fraction. So on top is going to be the number of objects. In this case, it's just going to be 3 for the 3 different segments. We don't actually have to use this 30. Since they're the same, there are 3 segments. Now, In the denominator of our fraction, we're going to have fractions themselves. We're going to have 1 over our first rate. We're going to have 1 over our second rate. And we're going to have 1 over our third rate. And so we can put all of that into our calculator. So we have 3 divided by 1 over 20 plus 1 over 60 plus 1 over 70. And this is going to give us 37.06 miles per hour. So that is our harmonic mean. So anytime you're trying to average rates, either like miles per hour, or maybe it's a density thing, where it's like, I believe liters per centimeters cubed or something like that. Anytime where you have this complex unit and you're doing an average, this is where you're going to want to go. So these are always 1. This is the number of objects you're looking at, and this is the actual rates themselves. And that is our harmonic. So those are the 3 main types of averages that we're going to look at. And you'll notice that I've got another type, but it's kind of a playoff of our arithmetic mean, the mean that we're used to. So weighted averages, you can commonly think of this as your GPA problem. So, for example, let's say we have a class schedule like this. We have a chemistry class, and we've got a writing class, and we've got a PE class. Maybe you're taking bowling, maybe it's health and wellness, whichever one. Each of those classes you have a grade for. So let's say you end up getting a C in chemistry, and an A in PE, and a B in writing. We're going to ignore pluses and minuses because that makes it more complicated. Remember that we're on a 4.0 scale, which means A is a 4, B is a 3.0, and C is a 2.0. We want to know our average grade for the semester, so some of you might be thinking, okay, 4 plus 3 plus 2, divide by 3. Unfortunately, it doesn't work like that because each class has a different weight in the form of the number of credit hours. So chemistry, since it's a lab science, has a 4 credit hour weight assigned to it. Writing probably has a 3 credit hour. And then let's say PE is a 2 credit hour. So that means, essentially in this context, what you want to think is, it is more important to do well in chemistry because it's given more priority. It's given a bigger weight, a bigger chunk of your grade. And A and P is great, but it only counts for 2 of your credit hours. So the way you figure out your GPA in this case is we then take the actual grade we got in the class, multiply it by its weight, and then we're going to add grade times weight and grade times weight, and then instead of dividing by the number of classes, we divide by the total weights. You can sort of think of this as each credit hour is given a 2.0, and each credit hour is given a 3.0, and each credit hour is given a 4.0. So we have 4 plus 3 plus 2 on the bottom, counting the number of credit hours. So we have 8, 9 is 17, plus 8 is 25, and we divide that by 7, 9, and that's going to give us 2.77 or 2.78 for our GPA for this semester of 3 classes. And you'll notice that if we switch the A and the C, we're going to have a higher GPA because the higher weight is therefore going to have a higher grade, even though the number of A's, B's, and C's are the same. And there we go. There is an explanation of means and weighted averages. So now you know what I mean when I say mean. because there's a lot of different context to what it could mean. See you next time.